guys, welcome back to online learning channel. Today we'll be doing Trigonometry Mathematics paper 2. Let me take you through my presentation. Welcome guys, this will be Trigonometry part 1 or lesson 1. So this is one of my favorite quote by Albert Einstein. He says education is what remains after one has forgotten what one has learned in school. So the focus of the lesson will be trigonometry. Under trigonometry, we'll look at revisions for grade 11, trig ratios. We'll look at the cast diagram. We'll look at the solving triangle with trig ratios. We'll also look at the special angles. We'll also look at the cofunctions. We'll also look at the reduction formulae. And lastly, we'll look at the negative angles. Now, revisions. So trigonometry is from the Greek word trignon, meaning triangles, and metron, meaning measure. This is a branch of mathematics that studies the relationship between side length and angles of triangles. So trig ratios, under revision, we'll use theta as a reference angle. So suppose this is your right angle triangle. So if this is your theta, so opposite to theta, you've got opposite side here, and then the side which is next to theta, we call it adjacent side. And then a side which is opposite to 90 degree, we call it a hypotenuse. So now, if we use a trig ratio sine theta, so sine theta will be opposite over hypotenuse, O over H. O over H. So for cos will be cos theta, which will be adjacent over hypotenuse, A over H. And then for tan, it will be opposite over adjacent, which is O over A. Now that way you'll come with SOHCAHTOA. So let's look at the theorem of Pythagoras. In any right-angled triangle, the square of the hypotenuse side, this is your hypotenuse side, is equal to the sum of the squares of the other two sides. So in other words, we'll say r squared is equal to x squared plus y squared. So this is your r, you square your hypotenuse, and then you add your adjacent and your opposite, your y. Now, if you use a trig ratio, it would be sin theta, which is equal to y over r. And then if you use cos theta, it will be x over r. And then if you use tan theta, it will be y over x. Now, let's do grade 11 identities, recap. This is a revision. So we've got a quotient identity, which is tan theta is equal to tan theta over cos theta, whereby your cos theta will never be equal to 0. And then we've got what we call a square identity, which is sin squared theta plus cos squared theta is equal to 1. If you make sin squared theta subject to the formula, you'll have 1 minus cos squared theta. If you make cos squared theta subject to the formula, you'll have 1 minus sin squared theta. Now, let's look at the example number 1. That's saying that triangle MNMP or MNP is a right angle triangle. Write down the trig ratios for sin alpha. This is your alpha. It will be opposite over hypotenuse. It will be MN over MP. And then sin beta, which will be opposite NP over hypotenuse, which is MP. Okay. Now tan beta and cos alpha. And then they're saying that if MP is equal to 13 and NP is equal to 5, calculate the cos theta, the value of cos theta. So now, sin alpha will be MN over MP. So say that, and then tan beta will be NP over MP, and then tan beta will be NP over Mn, and then cos alpha will be NP adjacent over MP. So now they're saying that if MP is equals to 13 and then NP is equals to 5. So first we must get this side. So we'll use theorem of Pythagoras. So MP squared is equals to Mn squared plus NP squared. So you say that your MP, you substitute 13 squared, your Mn unknown plus 5 squared. So 13 squared is 169 and Mn squared plus 5 squared is 25. So you make subject Mn subject to the formula, it will be 169 minus 25, which will give you 144. Then you get the square root, Mn will be equal to 12. Then your cos beta will be your adjacent over hypotenuse. It will be 12 over 3. Okay, this is simple. So let's look at the cast diagram. So the Cartesian plane, it has got 4 quadrants or 4 quarters. This is your first quadrant, this is your second, third, and your fourth. Here you have got 0 degrees plus 90, you have got 90 degrees plus 90, you have got 180 degrees plus 90, you have got 270 degrees plus 90, you have got 360 degrees. So here all A, we're saying that is cast diagram because here is CAST. We call it a cast diagram. Some, even though some, they say all students take chocolate, you know, all that. So here just know that A means that all trig ratios are positive, and then here for S, sine is positive, the rest are negative, tan is positive here, and the rest are negative, cos is positive here in the fourth quadrant, the rest are negative. So let's look at example number 2. If tan theta is equal to negative square root of 3 and 180 degree less than theta less than, so tan theta is negative where? In the fourth quadrant. Okay, that says determine the value of tan theta and 3 cos theta. So now you start by drawing your diagram. Okay, so now we know that it will be in the fourth quadrant because that way tan theta is negative. So now tan theta is equal to y over x. So we're given that is equal to negative square root of 3. So you know that there is over 1 here. So now your y is negative square root of 3, your x is 1. So it means that here your x is 1, and then your y, this side, is negative square root of 3, which is true because this side y is negative. And then now we have to get this side, the remaining side. You use the theorem of Pythagoras. R squared is equal to x squared plus y squared. So r squared is equal to 1 for x, and then for y is negative square root of 3 squared. So 1 squared is 1 squared, and negative 3 root 3 is equal to 3, which is equal to 4. Then our r is 2. So this side here is 2. So sin theta will be opposite over hypotenuse. So that will be y over r, negative square root of 3 over 2. And then for 3 cos theta, it will be 3 over cos theta, it will be adjacent over hypotenuse, which will be x over r. So 3 multiplied by 1 over 2, the hypotenuse, which equals to 3 over 2, which is 1.5. Now, let's look at example number 3. In the diagram below, the reflex TOP is equal to alpha. There's a coordinate of negative 5. So the coordinate here, you know that is x and y, negative 5 and negative 12. So here is your x here is negative 5, and then your y this side, it will be negative 12. So then determine the value of each of the following using ratios without the using of calculator. So your cos alpha, you know, first you must start by getting the hypotenuse side. So you start by getting the hypotenuse side here. So it will be r squared is equal to xy plus y squared. That should be simple. So you just add, it will be, you know, negative 525 plus 144, which is equal to 169. Then it means that your r, it will be root of 169, which is 3. So cos alpha, if this is your alpha, it will be adjacent over hypotenuse, which is 5, which is negative 5 over 13. This will be simple. And then for you to determine tan 180 minus alpha, so this 180 minus alpha is negative in the second quadrant. So you say negative tan alpha, and then tan alpha, this is your alpha, so it will be opposite over adjacent. So it will be negative 12 over 5. So let's look at the special angles. So these values are useful when we need to solve problem involving trigonometric functions without the using of calculator. You know, we look at 30 degrees and 60 degrees by using a equilateral triangle, you know. And then we know that in an equilateral triangle, you know, all PQR, all sides are equal, this 2, 2, 2. And then that is a set of two lengths, yes. So now when we have the triangle here, if here we've got all sides are equal, it means we've got 60, 60, 60, which is 180 degrees. So now if you divide here, you've got 30, 30. And then now, which will give us 30, because if here is from here, QR is 2, so it will be 1, 1. This side it will be 1. And then now, by use of a theorem Pythagoras, what we've been doing, you get this side PS, right? So it will be simple to follow. PR squared, this is your hypotenuse, it will be root of 3. This should be simple. And then now sin 60, these are special angle, sin 60, so it will be opposite over hypotenuse, root of 3 over 2. And then cos 60, it will be adjacent over hypotenuse, which is 1 over 2. And then tan 60, it will be opposite over adjacent, which is square root of 3 over 1, which is equivalent to square root of 3. So now for sin 30, so you will have opposite over hypotenuse, which is 1 over 2, and then cos 30, you'll have got adjacent over hypotenuse, which is root of 3 over 2. Then for tan 30, we'll have opposite over adjacent, 1 over square root of 3. This should be simple. So now, let's look at the special angle 45 degrees. So in other words, you've got special angles of 30 degrees, 60 degrees, and 45 degrees. Now we'll be using a isosceles triangle. So isosceles, it means that two sides here, AB is equal to BC. So which will mean that the base angle here is 45 and the base angle here is equal to 45 because the two sides are equal. So now here also you do the same. You get the unknown side, which is hypotenuse, so you get the IC, which will be sum of this squared, sum of this squared. So which will give you root of 2 this side by Pythagoras. So now, so tan 45, it's up to you, you can use this 45. So it will be opposite over adjacent, which is 1 over 1, which is 1. So sine 45, it will be opposite over hypotenuse, which is equal to 1 over root of 2. So, and then you rationalize, you multiply by root of 2 at the numerator and denominator. So you get root of 2 over 2. So cos 45, it will be adjacent over hypotenuse. It will be 1 over root of 2, which is, and then you rationalize, you get root of 2 over 2. So now let's look at the example number 4. Evaluate the following without the using of a calculator. So you've given 2 sin 30 plus 3 cos 60 minus 3 tan 45 and 3 into cos 30 squared plus 2 sin 30. So all these 30s and 60 and 45, 30s, 30s. So all these are your special angles. You don't have to use a calculator when you get problems like this. You have to use all those diagrams we're drawing there. Okay, so now you know that sin 30 is 1 over 2, so you'll have 2 multiplied by 1 over 2, then cos 30 is 1 over 2 plus 3 into 1 over 2, then minus 3 into tan 45 is 1 over 1, which is 1. So you'll have 1, 2 over 2, 1, and 3 over 2 minus 3, which will give you negative 1 over 2. So here you have got 3 into cos 30 squared plus 2 sin 30. All these are special angles. So 3 into root of 3 over 2 after rationalizing squared plus 2 into 1 over 2 squared. Sin 30 is 1 over 2. Then you'll have 3 into 3. Root of 3 is 3 over 2 squared is 4 plus 2 into 1 over 2, which is 9 over 4 plus 2 over 4, 11 over 4. This is simple. So now let's look at the co-functions. So we've got complementary angles. These complementary angles, they are angles that add up to 90 degrees. In other words, sine and cos, we're saying that are co-functions of each other. So check this out. Sine 90 degrees minus theta is equals to cos theta. That's in a first quadrant. So in other words, we're saying that whenever you have got 90, your sine will change to cos, right? Because these are complementary angles. So now this is how you do it. Sine 90 minus degree is in the first quadrant. So sine is positive, and then is it a cofunctions? Yes. So it will change to cos. And then when you have got sine 90 plus theta, 90 plus theta is in the second quadrant. Is sine positive there? Yes. It will be positive. And then is it a cofunction? Yes. So it will be changed to cos. Same will apply to cos 90 minus theta. It will be sin theta because these are cofunctions. And then cos 90 plus theta. So here you have got 90 plus theta is in the second quadrant. Is cos positive there or negative? Is negative. You write negative. Then sin theta because this is a cofunction. Okay. Now let's look at the interesting part. Most important, reduction formulae. So the reduction formulae hold for any angle theta. We assume that theta is an acute angle. In other words, it's less than 90 degrees. So function values of 180 minus plus or minus theta, 360 plus or minus, and negative theta, this function does not change. And then function values of 90 minus or plus theta. So here you've got a cofunction. So it means that sine will change to cos. So that's why we say the function changes to its cofunction, right? And then 270 minus or plus. But this 270 is not in your syllabus. For your syllabus, you've got only one cofunction, which is 90 minus or plus theta. So here, this reduction, it works in an anti-clockwise, right? So in other words, it's going in an anti-clockwise direction. So now let's look here. In the first quadrant, so we're saying that all functions are positive. It's true. That's why here you've got A, meaning all, right? So now sine, in other words, here you've got 0, we've said that. Here you've got 90 degrees, here you've got 180 degrees, right? So now and here is also a 360. If you have got sine 360 is here, we're going anti-clockwise. Sine 360 plus theta, it will be sine theta. Reason being that sine 360 plus theta, that's in first quadrant. Is sine positive there? Yes, it's plus. Is it a cofunction? No, it's not a cofunction. So you write sine theta, it does not change. For cos 360 plus theta is equals to cos theta, and then tan 360 plus theta is equals to tan theta, and then sine 90 minus theta. So now you've got a cofunction, it will be cos theta. So cos 90 minus theta, now you've got a cofunction, it will change to sine. So now here on the second quadrant, we're saying that S, meaning that sine is positive. So sine 180 minus theta is in the second quadrant, sine is positive, it's not a cofunction. Cos 180 minus theta, cos is negative there. So you write negative cos theta. Tan 180 minus theta, tan is negative there, tan theta. Sine 90 plus theta, this is a cofunction. It will change to cos theta. Cos 90 plus theta, that's a negative. It's not its position. It's negative sine theta. This should be simple, guys. Now, we also look at the last part. Here, if here you have got 180, here you've got letter T, meaning that the tan or tangent is positive. So sine 180 plus theta is in the third quadrant, so it's negative. It's not a cofunction. It will not change. Cos 180 plus theta is negative. Cos theta is not its place. Tan 180 plus theta is positive. It's its place. This for tan. So now in the fourth quadrant, cosine function is positive. So your sine 360 minus theta, sine is negative there. It will be negative sine theta. Cos 360 minus theta, cos is positive. It will be cos theta. And then tan 360 minus theta, negative. Tan is negative. Okay, it's not its position. So now let's look at the example 5. Find the value of sine 135 degrees without the use of a calculator. So now you have got, under solution, we have got sine 35. So it will be 180 minus 45 degrees. So sine 180 minus 45, which is equivalent to 135, is true. So now there, this is your special, 45 is your special angle. So you just play around special angles and you manipulate until you get this number. So it will be sine 45, right? And then now sine 45, which is equals to root 2 over 2 after rationalizing. Now, example number 6, simplify the following. Cos 135 multiplied by tan 45 sine 20 over tan 210 cos 70. So note that this you can manipulate, and then 45 is a special angle, and this you can manipulate it into a special angle. So for cos 135, it will be cos 180 minus 45, and then tan 45, you leave it, it's a special angle. Sin 20, leave it, and then 210, it will be tan of 180 plus 20. So you break it down, and then multiply by cos 90 minus 20 degrees. So now this cos 90 minus 20, here it will change because of its cofunction. So 180 minus 45, you say negative cos 45, multiplied by tan 45, multiplied by sin 20, all over by tan 30 here, it's true, multiplied by sin 20. So this, because its cofunction will change to 20, sin 20. So sin 20 and sin 20 will cancel. And then now you are left with negative cos 45, which is negative root of 2 over 2, tan 45, we say this one, all over by tan 30, 1 over root of 3. Then for you to change this division, the denominator will become the numerator, and the numerator will become the denominator. Then you will end up having negative root of 2 multiplied by root of 3 over 2 multiplied by 1, which is root of 6 over 2. And then example number 7, we've got simplified the following: sin 180 plus theta cos 360 minus theta tan 180 minus theta plus cos squared theta. This should be simple. So now, first you get rid of the brackets. It will be sin 180 plus theta is negative sin theta cos 360 minus theta, which is cos theta, tan 180 minus theta should be negative tan theta plus cos squared theta. So now here you've got a tan, you can change it to, it's a quotient, so you can change it to sin theta over cos theta. So this negative and negative will cancel, and then now this is a long division, so your numerator will become the numerator and the denominator will become the numerator. So you multiply it here, you will have cos over sin theta from here. So the sine and sine will cancel. Then you're left with cos multiplied by cos, which is cos squared plus cos squared theta, which is 2 cos squared theta. So angles greater than 360 degrees, what do you do if you have got angles? So we can add or subtract 360 or multiples of, so whenever you're giving an angle which is higher, so you can subtract for you to get in the range of 360. So we'll always end up with an angle in the first revolution. So example number 8, say suppose you have given sin 4/95, sin 44/95. So this will be sin 4/95 minus 360. So we said you must subtract or you add. So sin it, which will give you 135. And then now sin 1, it will be sin 180 minus 45, so special angles. And then sin 45, we say this root of 2 over 2 after rationalizing. So let's look at the negative angles. Always remember that negative angles are in the fourth quadrant. So clockwise here, now we're going clockwise when you do negative angles. Check this out. So you assign negative theta, just know that it will be negative sin theta. It's negative in the fourth quadrant, and then cos negative theta, it will be cos theta, because cos theta is positive in that angle. So suppose you're given tan theta minus 180 degrees, you start with an angle here. So you just come and take out the negative, then you will have 180 minus theta, then tan of a negative, you take out the negative, so it will be tan 180 minus theta. So 180 minus theta is also a negative tan theta. So negative and negative is positive tan theta. So now check this out also. If you have given sin theta minus 90, you do the same, you take out the negative, it will be 90 minus theta. So you take out the negative, sin 90 minus theta is positive. So, and then it's also a cofunction, so it will change to cos theta. And then cos of theta minus 90, you do the same, you take out the negative here, it will be 90 minus theta, then 90 minus theta. For a cos, we said it will be plus, and then cos of 90 minus theta, because it's a cofunction, it will be sin theta. So let's look at the example number 9. Determine the value of the expression without the using of a calculator. Cos of 420 minus sin 225 multiplied by cos of 45 divided by tan 315. So now 420, it will be 360 plus 60, then 225, it will be 180 plus 45, and then cos of 45. Here 315, it will be 360 minus 45. So you're just manipulating, with the special angles. So now 360 plus theta, it will be cos 60 minus, so 180 plus negative sin 45. Cos of negative is positive, it will be cos 45. Then tan 360 minus 45 is negative, tan 45, because this negative there. Okay, then now you have got negative multiplied by negative, which will give you positive. And then cos 60 is 1 over 2 plus sin 45 is 1 over root of 2. Multiplied by cos 45 is 1 over root of 2. All over by tan 45 is negative 1. So now this is simple. You just manipulate here. Root of 2 multiplied by root of 2, it will be 2 and 1 over 2. And then that should be, and then you've got negative here, which will give you negative 1. So now your home task, simplify the following. Sign of this will be our number A, and then your number B is this one, and number C, number D is this one, number E is this one, number F is this one. So if you've got any question here, you can write on the comments, we can assist. This is simple. You just use reduction formula. And thanks, guys. Don't forget to like, comment, and subscribe to our channel.